Hello students, welcome in the series of lectures on partial differentiation. In this lecture, we are going to discuss another important concept which is what? Homogeneous function and Euler's formula. That is, in this class, we will discuss that what exactly a homogeneous function is and what is Euler's formula we are having. So now let us start. Firstly, we will discuss what is homogeneous function. Then I will discuss the concept of Euler formula and what is the need of it. So let us start. Firstly, let us see what is a homogeneous function. Firstly, we are going to discuss about homogeneous function because the concept of Euler's formula, or we can say Euler's theorem, is based on the homogeneous function. So it's necessary to understand that what is a homogeneous function firstly. Let us see. It says that suppose that I am having a function f which depends on two variable x and y. That is the case of two variable, and it is said to be homogeneous function. It is said to be homogeneous function if the degree of each term is same. If the degree of each term is same, then the function is said to be a homogeneous function. For example, suppose that I am taking a function like x square minus 2xy plus y square, or let it be 2y square. This is the function and I need to check whether this is homogeneous or not homogeneous. So let us count the degree. The degree of the first term is 2. The degree of the first term is 2. The second one, it is what? X power 1, y power 1. So 1 plus 1, that is also 2. Degree of this term is also 2. You can see each of the term is having same degree. You can see each of the term is having the same degree, which is 2, and hence this function is a homogeneous function, and hence this function is a homogeneous function of degree 2. The simple way of checking a function whether it is homogeneous or not is what? Simply find the degree of each term and we are getting a unique degree. Then the function is said to be homogeneous, otherwise non-homogeneous. I am taking another example. Suppose that this time I am taking a function like f of xy equals to x cube plus 2xy square minus xy plus y to the power 3. We need to check whether it is homogeneous or not. So let us count the degree of the function. The degree of this term is 3. This is what? X power 1, y square. So 2 plus 1, that is 3. The degree of this term, 1 plus 1, that is 2. The degree of this term, that is 3. So you can see all the term is all the term is not having the same degree, not having a unique degree, because 3, 3, 3, and this term is having degree 2. So this term, which is the third term of the expression, make this function as non-homogeneous because each of the term do not have the same degree. So what I am getting, this is a non-homogeneous function. This is known as a non-homogeneous function in variable x and y. So I hope you understand the concept that how we can identify whether a function is homogeneous or not. Whether a function is homogeneous or not. Another thing, if suppose that I am having a function, these are function which is only having a single numerator only, means denominator is 1, we can say. But on the same time, if I am having a function like f of xy is equals to x square minus y square over x to the power 3 minus y to the power 3. Suppose that this is the function I am having. Now, how to identify whether a fraction function, it is a function, fraction function, because it is having denominator which is not 1. Now, how to check whether this function is homogeneous or not homogeneous? Simply check the numerator is homogeneous or not. If yes, proceed to check denominator. Denominator individually should be homogeneous, and if these function individually homogeneous, if these numerator and denominator is individually a homogeneous function, then the complete function, that is the numerator over denominator, is also a homogeneous function. And its degree is what? The difference, or we can say degree of numerator minus degree of denominator. So let us see. You can see in the numerator, it is second degree function. It is second degree function. So the degree of numerator is 2. What about degree of denominator? The degree of denominator is 3 because both of the term is having degree as 3. Now I can see numerator is a homogeneous function of degree 2. Also, the denominator is also a homogeneous of degree 2. So as a result, their fraction is also a homogeneous function. So I'm getting a concept over here. That is, this function is what? A homogeneous function. This function is a homogeneous function. And what about its degree? Its degree, student, is given as degree of numerator, that is n, minus degree of denominator, that is d. Numerator degree 2, denominator is 3. So I am getting its degree as minus 1. It means this is a homogeneous function of degree minus 1. This is a homogeneous function of degree minus 1. I hope you understand how to check a function whether it is homogeneous or not. I am taking one more example. This time, suppose a function is given as f of x comma y is equals to x square plus y square minus 2x upon x cube plus minus y cube. This is a function and I need to check whether it is homogeneous or not. I hope by directly seeing it, you get an idea that whether it is homogeneous or not. The answer is this is not homogeneous. This function is not homogeneous. Why it is not homogeneous? Let us see. Because you can see the degree of numerator is not unique. Means numerator is not a homogeneous function. Its degree is 2. It's 2. The last term is having degree as 1. Since the numerator is not individually a homogeneous function, so the whole fraction is not a homogeneous function. Why? Why it is not homogeneous function? Since the numerator is not homogeneous, is not homogeneous function, so, or we can say implies, function that is f of x comma y is not homogeneous, is not homogeneous. Even you can see the denominator is a homogeneous function of degree 3. But what is the condition in case of a fraction function? Numerator as well as denominator must be a homogeneous function. That is, numerator have a same degree term as well as denominator is having the same degree term. Then the fraction is said to be a homogeneous function. Otherwise, it is not a homogeneous function. I hope, students, you understood the concept that what exactly a homogeneous function is. Now I am moving to give its definition or standard notation. A homogeneous function in two variables, that is in x and y, is denoted by a0 x to the power n plus a1 x to the power n minus 1 into y plus a2 x to the power n minus 2 into y square plus up to a n into y to the power. This is the standard notation of a homogeneous function, and you can see it is a homogeneous of degree what? The degree of this term. Before that, I am just telling where the coefficient, that is a0, a1, a2 up to an, are what? Constant. These terms are what? Constants. These are the constant we are having. Another thing, I am going to calculate its degree. The degree of first term is n. The degree of first term is how much? N. The degree of second term, it will be n minus 1 plus 1. So this is also having degree n. The degree of third term, n minus 2 plus 2, that is n. And the last term is also having degree as n. How to find the degree of a term in which more than one variable is there? Simply add their powers. You can see all of the term is having the same degree n. So this is what? A homogeneous function of degree n. And this is the standard notation, students. This is the standard notation. Moreover, I can write the same term as what? I'm just reducing it in some another standard form. For that, I am taking highest power of x common from this expression. X power n is common. What left? A0 plus this will be a1, x power n is common. So this will be x power minus 1, which will be same as y upon x, plus a2. This will be x power minus 2. That is, I will get y upon x to the whole power 2, plus and so on an. This will be y upon x to the power n, which is equals to x power n into. You can see each of the term of this expression is having y upon x. The first term can be written as y upon x power 0, y upon x power 1, y upon x power 2, and last term is y upon x power n. That is, in place of writing this whole term, I can write a simple expression which is function of y upon x. It means what, students? In place of writing this lengthy expression, I can simply write x power n into function of y upon x. This is the standard notation, or we can say another standard notation of a homogeneous function. And what will be the degree of this function? The degree of this function will be n. A standard notation of a homogeneous function in two variable xy, and its degree is n. In the same manner, if I can take y to the power n common from the first equation, let me, this one is first, this will becomes as function of xy is equals to y to the power n into function of x over y. This is also another standard notation for a homogeneous function. That is what, students, I am getting three standard notation till now. One, which is given by equation first, two, that is equation 2, and 3, that is equation number 3. It is also a homogeneous function of degree n, of degree n. So this is how, students, I can decide whether a function is homogeneous or not. Directly we can decide, as we have discussed in some example earlier, and this is the standard form. And this is what? Standard form means if somewhere it is written like function of xy is equals to x to the power 1 upon 2 into cos of y upon x. What should I say? Is it homogeneous or not? Yes, it is absolutely homogeneous function. Why? Because it is equivalent to the form x power n into function of y upon x, because cos of y upon x can be written as function of y upon x. So this is what it is, a homogeneous function. It is a homogeneous function of degree. What will be the degree? Degree, do the comparison, n equals to 1 upon 2. So this is the benefit of reducing these two standard form, that directly we can do the comparison of the given function in one of these form and get to know whether the function is homogeneous or not and what will be the degree of this homogeneous function. Moving ahead, suppose that this time I am having another function like function of xy is equals to root of x plus y over x to the power 1 upon 3 plus y to the power 1 upon 3. Obviously, I think you understood that it is a homogeneous function. Yes, it is a homogeneous function. As you can see, the degree of numerator is what? This term is 1 upon 2. This term is 1 upon 2. So numerator is a homogeneous function of degree 1 upon 2. Denominator is also a homogeneous function of 1 upon 3. So the fraction is also a homogeneous function because the numerator individually is a homogeneous function and denominator individually is a homogeneous function. Now I am going to, that is done, that it is a homogeneous function and its degree is what? 1 upon 2 minus 1 upon 3. That is 6 into 3 minus 2, that is 1 upon 6. It is a homogeneous function of degree 1 upon 6. I am trying to reduce it in the standard form second or third. Let us see. Just take x power 1 upon 2 common from it. What left? 1 plus y upon x to the power 1 upon 2 over, take x power 1 upon 3 common from the denominator. So 1 plus y upon x to the power 1 upon 3. Take this into numerator, which will equals to what? X power 1 upon 2 minus 1 upon 3. The rest of the term, that is these term, you can see all of them is the function of y upon x, because 1 can be written as y upon x to the power 0. So the rest of the term can be written as function of y upon x, which will equals to x to the power 1 upon 6 into function of y upon x, which is a standard form of a homogeneous function with the degree is how much? 1 upon 6. So this is how we can reduce it. But when we are attending some kind of multiple choice question, no need to do these discussion, no need to do these description. Simply check the numerator degree, check the denominator degree, and if individually they are homogeneous, the degree of the resultant function is what? The degree of numerator minus the degree of denominator. This is what, students, we are having all about the homogeneous function. Now, another thing comes in mind why we are studying the homogeneous function. Because it is very useful when we are calculating some special type of partial differential. Some special type of partial differentiation when we are calculating. This is very useful along with the Euler's formula. That is, we are going to discuss the next Euler formula. And combinedly, when you are seeing homogeneous and Euler's formula, it will make partial differentiation of some standard function more, or we can say very easy. Means you can get their answer within the quick seconds, within the fractions of the second. So before moving to the question on partial differentiation, now I am moving to Euler's formula. I am moving to Euler's formula. Let us see. Let us see Euler's formula. Now, what Euler's formula is saying? Firstly, we will see its statements. Euler's theorem, Euler's formula. Let us see what it says. That it says that if z, which is a function of x and y, if z be a homogeneous function, if z be a homogeneous function of degree n, then it is having two results. First one, x into del z over del x plus y into del z over del y is equals to n into z. Second result, it says that x square into del 2z over del x square plus 2xy into del 2z over del x del y plus y square into del 2z over del y square equals to n into n minus 1 with z. These are the two results that we are having about the Euler's theorem for a homogeneous function. Means suppose that a function is given to us and the question is asking the value of this one, that is x into del z over del x plus y into del z over del y. If you are solving it in the detailed manner, like firstly find del z over del x, do multiply it by x, then del z over del y, do multiply by y, then you will get the result. But by using this theorem, directly you will get the result and its value is n times z, that is n times the given function. In the same manner, if I am talking about the second result, it is a quite lengthy process for finding second order derivative of z with respect to x. That is the first one, do multiplication with x square. Then second order derivative of z, x and y, multiply by 2xy. In the same manner, third term, then simplify and get the answer. But if I'm using the Euler's theorem, it will make our work very easy, that we will get the answer in the fraction of time, and its value is what? N into n minus 1 with z. Means simply what we need to check? Check whether the function is homogeneous or not and find its degree. Only two steps you need to do. What? The first one, check whether the function is homogeneous or not. The second one, find its degree, and then you will get the answer by putting in these results. Whether if they are asking this one, so it's simply n times z. The second one, n into n minus 1 into z. Moreover, we can just extend this result up to any number of variable. Like this is the case of two variable. If we are having three variable, then third term will be added, four variable, four term will be added, and so on. So before moving to the question, I'm just going to a quick proof of these results. Let us see how we will prove these one. Since it is given that the function is homogeneous, so let z be a homogeneous function, and there are two standard notation for homogeneous. One is x to the power n into function of y over x, and the second one is what? Y power n into function of x upon y. Simply whatever variable is outside, that will be in the denominator. This is how we can remember the things. Now let us try to prove the result. I am taking z as a homogeneous function. I am finding firstly del z over del x. That is the differentiation of z with respect to x. So I should apply the product rule of differentiation because two functions are there. First function as it is, differentiation of f, that is f dash x power n, differentiation of f is f dash y upon x, moving inside y upon x. Moving inside the function, I see the term y upon x, and we will do its differentiation for x. So y constant as it is, 1 upon x will be minus 1 upon x square, plus this time function of y upon x as it is, x power n differentiation, n into x to the power n minus 1. This is what I am getting del z over del x. But in the result, it is x time. So do multiplication by x for this equation. So x into del z over del x. This will be how much? X into x power n function of f dash y over x. This is what? Minus y upon x square plus x into nx n minus 1 function of y upon x. This x got cancelled by this 2. So finally x power n, and this is x. So minus y into x power n minus 1 into f dash of y upon x plus this will be x power 1 x power n minus 1. So x power n minus 1 plus 1. So only x power n function of y upon x. This is one of the term of the Euler's formula. Let it be first. Once again, do the differentiation of the given function z with respect to y. So now del z over del y. So del z over del y will be how much? If I am doing the differentiation with respect to y. So x power n constant as it is, f will be f dash y upon x into y upon x is how much? 1 upon x. 1 upon x as it is, and y differentiation 1. We should not apply the product rule over here. Why? Because x is a constant for y differentiation. Do the multiplication by y. So y into del z over del y equals to y times, this is x over here. So comes over here. So x power n minus 1 into f dash y upon x. Let it be second. In order to get the Euler's formula result, just add equation number first and 2. If I add them, you can see this term got cancelled. If I add them, minus y x power n into this cancel by this much, and this result will left. That is, I am doing that, add the equation number 1 and 2 or 1 plus 2. So left side will be x into del z over del x plus y into del z over del y is equals to x into del z over del x is what? Minus y into x power n minus 1 into f dash y upon x plus n into x power n into function of y upon x plus equation number 2 y into x power n minus 1 f dash y upon x. This got cancelled by this much. What left? Only this result. So this will be x into del z over del x plus y into del z over del y is equals to n into x power n into function of y upon x. And this is how much? If you remember, I just assume it as z. So finally, x into del z over del x plus y into del z over del y is equals to n times z. And this is the result number 1 of Euler's formula, or we can say Euler's theorem. In the same manner, we can prove the second result also. But when we are solving the question, no need to just prove the result again. Directly, we should use the result number 1 and result number 2. I'm just naming them as, this is the result number 1 and this will be the result number 2. Remember, these are applicable only for homogeneous function. If the function is not homogeneous, we cannot apply these two results. The second result proof, I am leaving it for your exercise. In the same manner, you can prove the second result also. Now, let us see some of the applications or some of the problem based on these two results. The first one I am taking, remember the first thing is that the function must be homogeneous, otherwise the theorem and this concept is not applicable on it. Let us see a question. The question is, if z is equals to x power 1 upon 3 plus y to the power 1 upon 3 upon x to the power 1 upon 2 plus y to the power 1 upon 2. This is the given function. They are asking find the value, the first one, x into del z over del x plus y into del z over del y, first one. Also, they are asking the second one, which is x square into del 2z over del x square plus 2xy into del 2z over del x del y plus y square into del 2z over del y square. These are the two results they are asking. The first thing is that if I am solving them in the descriptive manner, these two parts at least take 10 to 15 minutes if you are good in calculation. But if I'm using the concept of homogeneous and Euler formula, it will be solved within the fractions of time. Let us see how. The first thing we need to check whether the function is homogeneous or not. You can see the degree of first term is 1 upon 3. This is also 1 upon 3. That is, both the term is having same degree. That is, numerator is a homogeneous function. Numerator is a homogeneous function. The same for the denominator. The degree of this one is 1 upon 2 and this one is also 1 upon 2. What I get? I get numerator individual is a homogeneous function of degree 1 upon 3. Denominator is also a homogeneous function individually of degree 1 upon 2. It means what, students? This function is a homogeneous function. Because I told you when the function is in the fraction, simply check numerator is homogeneous or not and denominator is homogeneous or not. Moreover, what will be the degree of this function? As I told you, degree is degree of numerator minus degree of denominator. So this will be how much? 6, 2 minus 3. That is, I am getting n equals to minus 1 upon 6. The value of n is evaluated. Now the question is done. The first result, according to Euler formula, n times u. Since it is z, so I should write n times z. It is not necessary that always it is z. It may be anything like z, w, u. According to that, I should write the result n times z. N is minus 1 upon 6 into z. So this is the answer of the first part. You can see we have solved this question in the fraction of time. Which is what? If I am writing in the descriptive 1 upon 6, put the value of z. So x power 1 upon 3 plus y power 1 upon 3, x power 1 upon 2, y power 1 upon 2. This is the result of the first part. I hope you understood. Moving to the second one. Second is what? N into n minus 1 into z, which is n is minus 1 upon 6 minus 1 upon 6 minus 1 times z. So minus half, and this will be how much? Minus 6 minus 7 upon 6 into z. So 7 minus 7 plus 7, that is minus 7 and minus 1 7 upon 36 into z. Moreover, if you need to put the value of z, you can do that also. X power 1 upon 3, y power 1 upon 3 upon x power 1 upon 2 plus y power 1 upon 2. So these are the answer of these two results, students. I hope you understood the concept that how we can apply the theorem. But remember two things here. The function must be homogeneous. The second, how to find the degree. And simply apply the result of Euler formula. Moreover, if question is asking something different of these two expressions, we cannot apply the Euler's formula. We cannot apply the Euler's formula. That applicable only if the question is asking these two parts. Let us take one more example. This time z is given as root x plus root y into x to the power n plus y to the power n. This is the function we are having, students. And the question is asking the same two result, that is find first part that we have already done, x into del u over del x plus y into del u over del y. Why I'm writing u? It should be z, na? Yeah, because the function is z. In the previous one, let us check whether I am writing z or u. It should be whatever the function is given to us. Yeah, it should be z. So this is the function is given, z is this much, and they are asking the result of Euler's formula. So let us see how to find them. What they are asking, x into del z over del x, y into del z over del y, first part. The second part, the same one, x square del 2z over del x square plus 2xy del 2z over del y square del x del y, sorry, plus y square into del z over del y. The same the question is asking from us. Let us see. The first thing is that we need to check it is homogeneous or not. So I am going to multiply these two terms. Root x, x power n will be how much? X power n plus 1 upon 2 multiplication plus this will be x power half y power n, then x power n y power half plus y to the power n plus 1 upon 2. The degree of this term n plus 1 upon 2. The degree of this term n plus 1 upon 2. The degree of this term n plus 1 upon 2, and similarly the degree of this term n plus 1 upon 2. Each of the term is having the same degree. It means what? This is a homogeneous function. Homogeneous function of degree. What will be the degree? N plus 1 upon 2. So the answer of the first one is what? Degree into z. So n plus 1 upon 2 into z. The first one. The second one will be what? N plus 1 upon 2. That is n into n minus 1 into z. Simplify. So n plus 1 upon 2. This will be how much? N minus 1 upon 2 into z. You can see how quickly we are solving these kind of question in order to get the required result. One more question I am taking. This time z is f. In place of z, the function is given as f. X square upon y square plus y square upon z square plus z square upon x square. And they are asking find the value of x into del f over del x plus y into del f over del y and z into del f over del z. This is the question. Now the thing is that students, till now we are solving the question of two variable only. But here f is the function of three variable x, y, z. So we need to extend the result up to three variable. I'm writing the extension firstly. If suppose that f is a function of n variable x1, x2 up to xn, be the given homogeneous function, be the homogeneous function of degree n. I'm just writing the extension of two variable up to n variable. Then it says that x into x1 into del f over del x1 plus x2 into del f over del x2 and xn into del f over del xn. It should be n times f. N times f. N is what? N is the degree of the given function. N is the degree of the given function into the given function f. That is, the result is almost same. So this should also be equals to n times f. Now I need to find the value of n. What is the degree of first term? Numerator minus denominator 2 minus 2 0. Numerator minus denominator 2 minus 2, 2 minus 2. The degree of this term is how much? 0, because each and every term is having degree 0. It is also a homogeneous function. So 0 times f, that is the result is how much? 0. Or you can do another thing. If you are not writing numerator minus denominator, take these term into numerator. So the first term will be x square into y to the power minus 2. Degree will be 2 minus 2, that is 0. It is also 2 minus 2. This is how we are finding the degree of this homogeneous function. I hope you understood the concept. One last question on this concept. If f equals to, case of two variable, f is a function of two variable and the function is look like this. This is the function we are having. Let us see, and the same thing they are asking, find the value of x into fx, that is del f over del x, y into fy, the first part. Also asking the second one, x into fxx plus 2xy into f of xy plus y square into f of yy equals to what? Now they are the result of the Euler's theorem. So we should check whether the given function is homogeneous or not. Let us see. This will be x to the power minus 3, or we can say numerator is the homogeneous of degree 0, or we can write it as like that. It will be better like this, plus x cube plus 5y cube to the power minus 1, like this. What will be the degree of first term? Minus 3. Degree of second term? Minus 2 minus 1, that is minus 3. Degree of this much? X power minus 3, 5y power minus 3. And if I take in this term, I am taking x cube outside, it will be x power minus 3. What left? Function of y upon x. So its degree is how much? Minus 3. It means each and every term is having degree as minus 3. So by Euler's formula, this will be n times f. That is how much? This will be minus 3 times f, and this will be n into n minus 1 into f. N is minus 3. So minus 3 minus 3 minus 1 into f. So minus 4 into minus 3, 12 times f. So this is how, student, we have used the homogeneous function concept and Euler's formula for getting some standard result related to the partial differentiation. In the next class, we will discuss if the function is not homogeneous. Till now, we are solving for homogeneous only. In the next class, we will discuss if the function is not homogeneous, then how we find these results of Euler's formula. How the result of Euler formula can be obtained. So that's all from my side, students, for this lecture. Thank you. Thank you very much for your attention.